Hey, good morning, everybody. Hope everybody had a good weekend. So, any questions?
Yeah, I had a question on PA4.
Mm-hmm.
I am working with three other people that are from the other class, and you said we were presenting this.
Mm-hmm.
So how would that work if I have the other three people in your other class, but I'm in this one?
So, it's up to the people in the group how you want to work the presentation. Um, but I'm going to go through as people tell me that they're in groups, and I've only gotten 2 groups so far. But the groups that are formed as of Wednesday, I'm going to go through and basically number those, and then pick a random order. And so I'll say, first we're going to do group this and group that, and whatever order your group is supposed to present in, um, you can choose whether you're going to present it or one of your 3 group mates are going to present it. Um, and whoever's going to do it, they'll just present in turn during their class. You don't need to have everybody there to do the presentation. Now, if you want to do the presentation, you could do a second presentation by yourself in this class.
Okay.
But it's really up to the people in the group. All right. Other questions on PA4 logistics or the dialogue command or things like that?
I had a quick question on an issue that I'm having,
Mm-hmm.
and maybe it's relative to Bash, but I have a script that I use to get my appointments,
Okay.
and it seems to run flawlessly, whereas it like checks and makes sure that it's not a past appointment, all that stuff. And then when I call it in my program, it crashes the whole thing.
How does
Which
it
is
crash
really
it?
weird because, well, so I'll go to my main program. I have start with a menu, right? And so you can pick your selection, which one you want to do. And it
Okay.
was working fine before I implemented the test to see if it was a pass one. And so I know that it's written right, but as soon as I hit make an appointment, it pops up the calendar, what day, and no matter if I pick the day in the past or a day in the future, it just freezes, and then I'll go to Control C to get out of there, and then everything just starts glitching and stuff.
Hmm.
So it seems really weird that it works on its own and it worked before. I don't know if it's just maybe too much trying to happen or
You're probably not going to overload the system, so it's not something like that probably. Um,
yeah.
but if you're trying to run one script from another, things can change sometimes. Um, Especially with things where we're trying to do interactions. So I would suggest whatever the mechanism is that you're trying to do, try to make yourself a simple test case. Right? Maybe instead of a calendar, instead of checking to see if it's in the past, just try to, create a basic input box that just reads, a few words from the user, and see if you can either get that to work or reproduce the problem, and then you have a simpler thing to drill down on.
Okay. So you think like maybe instead of pick a date on the calendar, end with the date in this format, and then do that and see if that works?
Yeah, or like I say, just try maybe an input box, and see if you can get that to work or reproduce the error.
Okay.
And definitely come by office hours, right? And we can actually look at the code and figure it out from there. But always, if you can dig out from, say 50 lines of bash, a 2 or 3 line example that reproduces the problem, that's a whole lot easier to work with. And
Yeah.
sometimes in the process of doing that, you'll actually discover what the problem is. But yeah, come by office and we can definitely look at it.
Okay. Yeah, I'll try to do that tomorrow.
Okay, cool. Well, everyone's anxious for an attendance ping, so let's do an attendance ping. Let me know you're here. Go ahead and send me a note unless you just did. Or you can send it again, that's fine.
I do have another question on the BA4 program.
Yeah.
I don't know if we're going to go over this or not, but one of the requirements is to be able to delete an appointment.
Mm-hmm.
You have to literally be able to go in and just delete the whole thing, right? Not like create an edit box and like delete the line in the edit box.
So you want the user to be able to say, to somehow specify an appointment that they've created and say, delete that from my calendar. And whether that, removes it from the file or adds a mark to the file saying this has been deleted, or does something else, that's up to you. And how you want the user to do that deletion is up to you, but it should be something reasonable. They shouldn't have to write binary code or something.
Sure. I know that Dialog has a built-in edit box where it opens, it basically can look at the whole contents of the file and then you can go in and edit. So each line is an appointment and you can go in and just delete out.
Yeah, I wouldn't do that. Because just from kind of a user safety point of view, you wouldn't really want to expose the entire database to the user, because if they changed, like one of your field separators from a pipe to something else, then you got all kinds of issues being introduced. And you probably want your script to be the only thing that can kind of have free reign over your file.
Okay.
How should appointment viewing be handled? A list of upcoming appointments, have the user select a specific date to view appointments only on that day, or is it up to personal taste? Mostly up to personal taste. So let me make sure I don't inadvertently change the assignment here, and let me go back to the actual PDF for PA4. And so look at all upcoming appointments. So at the very least, you want to be able to say, show me all upcoming appointments, and have your program, look at the current date and then show you any appointments that haven't already happened in the past. And you can, present those in a big list. You can just make a file and have one appointment per line or whatever you choose. And then other things like showing appointments on a particular day and stuff, that would fall under additional features, and you can pick and choose those as you like. While you're thinking about these things, don't ever underestimate the value of temporary files. And temporary files can become, something that becomes a problem, but if you use them carefully, they can make your life a lot easier. And so for example, if you have a directory, right, so I've invited you to create a directory under /temp/calendars, and whatever you want to call your directory, so maybe your group name is Teenage Mutant Ninja Turtles, so you work under this TMNT subdirectory, right? And maybe you have a main calendar .dat, and maybe you have some temp file 1 and maybe a temp file 2, and you can have these files that are for use by your program, but can help you do some processing. So for example, if you want to look at future dates, you could, you could take your calendar program and rearrange the fields so the date is listed first, if that's not the default. And then you could sort them, and then you could march through until you find something that's in the future, or whatever, right? But temp files are oftentimes useful, and you want to be a little careful about just sort of arbitrarily creating files in your current directory. Because I might, run your calendar program from my directory. I might already have something called temp file or main calendar.dat, and if you start creating files that conflict with my existing files, that's considered poor design. But you can set up a directory under /temp/calendars, and then you can do whatever you want in there. You can store your main calendar file, but also temporary working files and so on. And sometimes, if you don't have a dedicated area where you can do this, sometimes you go ahead and you make hidden files. And you make, something in your current directory like, temp cal file or something like that. That's still considered kind of like not super great form, because if somebody runs your calendar program from 100 different directories, then you end up with 100 directories with 100 of these mysterious temporary files in them. But sometimes programs will make temporary files under the user's home directory, and then maybe you've got one temporary file that your utility is creating, and that's usually not considered too horrible. And if I look in my home directory, all of these files that start with a period, these are probably files that were created by some other utility. So when I install the Arduino software, it creates a .arduino file. It's probably a folder. When you install Firefox, you get a .mozilla file. When you install Minecraft, and so on. And this is usually acceptable, right? And this is all in my home directory. And so you can think about if that's going to help you. All right, other questions? So something that we talked about in the previous section, and I don't think we've talked about this formally yet this quarter, and it's something that comes up, and I've used these concepts, but I don't think we've actually addressed them from the beginning. So let me talk about file paths. And this is a general concept. A path is sort of how you get to a file. Right, so remember our file system is organized as a tree. There's a root directory, which is called /, and underneath that there's a USR directory, there's a home directory, there's an ETC directory, there's a bin directory, there's a bunch of other directories, and there's a few files in there also. And so if I do an ls on /, let's do an ls-l, right? I got lots of directories: media, mount, opt, proc, root, and so on. I've got a few files like swap file, and I've got some links like flash backup and init rd.image and so on, right? So this is a hierarchy of files, and under each of these directories there's usually subdirectories. So under etc there, I think there's a sys. Under home there's a nic. Under home there's a pi, and so on. And we can move into one of those subdirectories. So if I start off at /, there's all the stuff under /. If I move into home, there's all the stuff under home. If I move into nic, there's all the stuff under /home/nic. If I move into CSE224, I'm now in a new directory, /home/nic/CSE224. There's all the stuff contained in there. And I can go down into a subdirectory from that, and I find different files there. And I can go into a deeper subdirectory from there, and I can find new files in there. So there's this whole hierarchy. And so in my deeper dir, I have a file called deep file. right? How do I know it's a file and not a directory? Well, I can do my ls-l, and there's no D in the beginning, so this is just a plain old file. And to find this file, right, I can always start from this root directory, this slash, and this directory tree basically tells me how to find it. It's under /home /nic /CSE224, etc. And so this is the file, but the path to the file would be /home /nic etc. And so there's the file, there's the path leading to it. And the reason this comes up is because there's two ways to specify file paths. There's absolute and relative paths. And a relative path is usually what we're working with, and it's basically a way to describe something like this. But it's a description that's based on where you are right now. So for example, if I've logged in and I'm sitting in this directory, I could say, hey, show me the file in CSE224 /subdir /deeperdir /deep file. And I didn't start with a slash. I didn't say start at the root of the tree. I started with CSE224. And if I just start with something, other than a slash, it assumes this is relative to where I am right now. So if I'm currently sitting here under /home /nic, it's my home directory, and I say let's look at what's in CSE224, it's assuming that's a subdirectory underneath where I am right now. So if I go to my home directory, I can say ls CSE224, and it's looking for it under /home /nic. Now if I go to a different directory and I type that same command, I get an error. Because now I'm sitting under this different directory, /home /nic /public HTML. And there is no CSE224 directory underneath this. So a relative path like this depends on what directory you're currently in. And this is usually what we're working with, right? If I want to know what's in this q2.py file, I can just say cat q2.py. Since I didn't specify a directory in front of this, it assumes this is in my current directory. And so it'll show me the contents of that file. Now if I'm sitting in my home directory and I say show me what's in this q2.py file, well, there is no such file in there. But I could say show me what's in the subdirectory public _HTML, and in that directory the file q2.py, and it'll show me the contents of that. So this is also a relative path. And it's saying starting with what directory I'm currently in, which happens to be my home directory, go into the subdirectory public HTML, and in there look for a file q2.py. So those are relative file paths. And two things to know related to relative files are dot and dot dot. So dot's always a synonym for your current directory. So I'm currently in the directory CSE224. If I say ls dot, well, dot means /home /nic /CSE224. It's my current directory. It does exactly the same thing as just in ls. If I say cat dot /t2.c, that means in my current directory, look at t2.c. Dot dot means move up one level. So here's my current directory. If I say ls, it shows me that's this current directory. If I say ls dot, that's my directory. If I say ls dot dot, that shows me one level up. So if I'm sitting right here, dot dot refers to nic. If I'm sitting down here, dot dot refers to subdir. if I'm in my home directory, dot dot refers to home.
Just to be clear,
Mhm.
when you say up, you mean closer to the root?
Closer to the root, yeah. So if I'm in CSE224 and I want to look at something in public HTML, right, I can go up one level and go down to public HTML. So I'm sitting right here in 224, I can say ls dot dot slash public HTML, and I'm basically going up and down, but down a different path. So from here I could look at a file in public HTML like q2.py by using this dot dot. But again, this is relative. If I'm in a different directory, that same command will throw an error. Because if I happen to be sitting here, dot dot slash public HTML doesn't exist. But if I want to look at user Pi's home directory, or Chewbacca, right? So here's what's in the home. I can say ls dot dot slash Chewbacca, and I can see their directory. They haven't done anything. Alright, so those are relative. Absolute paths simply begin with usually a slash, and they specify the full path. So if I happen to be sitting here, I could say ls slash home slash nick slash public HTML slash q2.py. And it doesn't matter what directory I'm in. I could be sitting in slash and that command works. I can be sitting in slash etc and that works. Right? This slash in the beginning basically says start off at the root of your directory tree. So that slash is this thing right here. And then slash home means this thing right here. Slash home slash nick means this, and so on. And so that's an absolute path.
So I got a quick question.
Yeah.
It's kind of pertaining to PA4, but also files and whatnot in general. You mentioned earlier if you create an appointment under Tyler, and then you create an appointment under Sally, you don't want to show Sally all Tyler's appointments, right?
Mm-hmm.
So could you declare your file name as like a variable where you capture the user's name and create a specific log file for that user?
Yeah, you could.
You can do that with that, like you could say like log file underscore and then dollar sign whatever there.
Yep, that'll work great.
Okay.
So a couple of comments on that though. So first one, you're not required to support multiple users. So if this is an added feature, that's cool. But you're assuming that you're running this, and whoever's running this, with a calendar file, that's their calendar. If somebody else runs it, they have the same calendar. So you're not required. Say again?
As an additional feature?
So you could do that as an additional feature. You could have like a login or something at the beginning, like what's your name, and then you could keep track of separate appointments.
Alright.
And there's a few ways you could do that. You could put a username in the beginning of each record, and if you're logged in as Nick, right, only deal with records named Nick. Or you could do what you described, right? You could have a file called Nick and a file called Chewbacca, and if you log in as Chewbacca, you just work with Chewbacca's calendar. That would be kind of a more standard way to do it. But this gets into another interesting side conversation, which is injection attacks. And this is, not a practical concern because you're writing this, you're running it, you're demoing it, right? But just for the sake of argument, suppose you had, something running on your system that people could access through the web, and they could put in their username, and you would open, slash log file underscore whatever the username is. So what can happen is a clever user who knows your name, who knows your code, could say my name is guest slash dot dot slash dot dot slash dot dot slash etc slash password. And if this is what name is equal to, and you substitute that in here.
We're
We're
not
not
seeing
seeing your screen.
Oh man, this was glorious code. There we go. All right. So suppose that you're gonna open log file _ $name, and suppose they say, oh, my name is guest slash dot dot slash dot dot slash dot dot slash etc slash password, right? If you take this string and you substitute it right here, and you try to open a file like that from your bash script, you're going to open something called log file _ guest slash dot dot slash dot dot slash dot dot slash etc slash password. And if you're not careful, they can actually like start directing your script to manipulate the system password file. And if your script happens to be running with the permissions needed to do that, they can now basically go through the calendar interactions, but in the process, at least corrupt or possibly look at or manipulate a file that you didn't intend them to. And this is a common version of attack, right? It's an injection attack. So this happens like when you have a web page that's generating queries for a database, and somebody can say, tell me what you're looking for, and you're supposed to type in the name of a food that you're looking for in the store, right? But you can type in a very long string that basically creates a new query and can do things like delete tables or change permissions or things like that. So just something to keep in mind. It's obviously not an issue for this class because we're just writing stuff for ourselves. But like if you take a security course, you'll play around with this kind of thing. And SQL injection in Bash is not all that common anymore, although past few years we've actually seen some bad attacks once in a while. But it's very common with databases. And so this is, Bobby Tables. If you don't know who Bobby Tables is, Google it. It's a XKCD comic about SQL injection. And it kind of captures the essence. All right, so that's kind of a sidebar, but it was a good point to mention it. All right, so what else can I tell you about path names? Absolute relative. Oh, last thing is tildes. So tilde is an abbreviation for your home directory. So let's I'm sitting under a directory like this, and I want to look at something from my home directory's public HTML, right? I could do ls/home/nic/public HTML, but I can also use a tilde to represent this part of my path, to represent whatever my home directory is. So I can say ls/public HTML, and that shows me what's in public HTML under my home directory. And on a typical Unix system, there's always this public HTML directory under your login directory. So this one ls command should work, more or less on any Unix system. So if I'm on the Linux server, that's what's under public HTML of my home directory there. Even though my name might be, my directory might be /home/nmacias, right? The tilde always refers to your home directory.
So, can I ask how you share information from one to another? So, like, say you wanted to use the username, right? And you have to get it from one part of your program, but you have to use it in one of your other scripts at the same time, but you don't want to ask the user 3 times what their name is. So how do you just pass that variable from one to the other?
So when you say one script to another, are you thinking of scripts in different files, or one?
No, same file. So like, say you're starting your program, you say, who is this?
Mhm.
Skyler. Okay, then you go down, and now you want to make an appointment. You have that as a separate script, same file, but it's like, that's just handling only your appointments.
So like,
So
are you thinking of a function inside a script?
yeah, like a function.
Okay.
Basically. So, but it's written as like mine is one is appointment and the other one is PA4.
Okay.
So PA4 runs the main program and then I have my appointment function. So how do you pass the usernames? Like, here you go, take this information without asking the user?
So there's a few options. In Bash, it's not too horrible to use global variables. Right, so if I do this, the user will type in a name, that'll go in this variable username. That's pretty much available throughout my script. Let me see if I can remember how to do functions. Whoa.
That's cool.
That's a little strange. Oh. Yeah, it displays a keyword in my setup. All right, that was a long way to get there. So this variable that I read in here is accessible throughout my script, right? Once I've given it a value, I can access it even inside this function, just by using the name of that variable. So you can have globals, and for C programs we really never want globals. For Bash you can get away with it and justify it sometimes because argument passing is a little weird. But another option would be to call your function and pass it as an argument, and then I can pick up that argument inside my function. I can pick up the first argument as $1, and so when I run this and I say I'm Nick, it can say hello Nick, and that's maybe a slightly cleaner way to do it, depending on how much information you have to share. And so if I wanted to share, the current date and the username and some other information, right, I could string those all out as a set of arguments, and then in here I could access those as $1, $2, and so on. And you can make it a little less unpleasant by renaming $1, $2, etc. to something more reasonable. And so have a variable called name that's equal to $1, and then it does the same thing. But so there's different ways to do that. But I'm not too worried about globals in Bash. Just the reason we don't want globals is because they tend to bite you after a while. So if you have one global variable, you're probably okay. But if you start having 10 different variables that are shared throughout the entire script, it's really easy to find yourself doing something you didn't mean to do. Changing a variable when you thought you were changing something else, or working with a local that ends up being global, or things like that. So arguments are usually pretty good.
And can you use, so since most of this is going to be we're using the info box, can you get that and then just do a read command for whatever that variable is?
To get the output of a, say that again?
So I'm using an info box saying, what's your name?
Mm-hmm.
Type in, my name is blah, 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 whatever.
Okay.
Can I use the read command after the dialogue has already gone through to capture that variable?
No, but you can do something like username equals backquote. dash dash input box, who are you, with a typo, height and width, and then do this output FD trick.
Okay, so that will actually save it as a global?
So this will run the dialog command, right? Ask you who you are. When you're all done, dialog will output what the person typed in. The back quotes will say, okay, take that and store it in this variable username, and that should be global at that point.
Okay.
And you can either use it as a global or you can pass it as a name. But yeah, it should work fine as a global.
So as long as it's in the same directory, it should be all, everything should share information.
So as long as it's in the same script, right? We're not actually writing anything to disk here. We're just declaring a variable inside this instance of bash, right? Because when you run a script, you're basically running bash and telling it what commands to execute. So as soon as you give a value to this variable, that value basically persists. But if I call another script at some point, if I had a separate file called display and I called that file, it would not know about username unless I use that export command to make this thing appear in new shells. But if you're all in one file, this should work fine. Alright, cool. Let's talk about the ODP. So ODP 414 is posted. And we're back to ODPs. You're going to have 4 ODPs this week. ODPs 414, 16, 17, and 18. 414 opened at 8 this morning, but usually they'll open at 10:05. They'll be due at 10. So you have time to look at these ahead of time. The readmes are all posted on the server already. So you can look at those, and my suggestion is, finish this ODP as soon as you can. Look at ODP 416. If you're not sure how to do it, come to office hours tomorrow morning and ask about it, right? And then it'll open at 10 o'clock. You can try it and hopefully get it to work. And then before Wednesday morning, look at ODP 417. And if you're not sure how to do it, come to office hours and we can talk about it Wednesday morning, right? But try to stay ahead of these things, right? 417 is due Thursday morning. Don't try to come to office hours Thursday morning to ask questions about that, because by Thursday, office hours are getting full. You might sit in there for an hour and you have to go to class or something. So you can look at these readmes ahead of time and sort of get a head start on them. And all of these ODPs are similar to each other. They're all related to string processing. And this is the topic we want to dig into somewhat this week, and this is where your last programming assignment is going to come from, is string manipulation. So we're gonna dig more into the idea of strings in C. And remember, a string in C is just an array of characters. So really, what we're doing is we're manipulating arrays, and that's a really useful thing to know how to do in general. But arrays of characters for us represent strings. So let's look at ODP 414. And so you're writing a function called mix, and mix does the following: it takes 2 strings and it interleaves the characters and creates a new string, which is this third argument, which I'm calling out. Creates a new string which is a mix of the first 2 strings. And so let me give you an example of this. Wonder if I've still got one. I don't think I do. There we go. All right, so here's an example of how this mix function would work. So I'm doing my function prototype, and I'm making a pair of strings. String 1 contains the string hello, string 2 contains the string funny. And out is an array of 120 characters. Actually, let me make these a little easier to work with. And mix should take these two input strings, produce an output string, which will be what you get when you shuffle these two together. And so the output string, the first letter should be A, the second letter should be V. The third letter should be B, the fourth letter should be W. And it should just mingle these two strings together. And so if I run this, here's what I get. A, V, B, W, C, X, D, Y, E, Z. And so if you think of it in terms of indices, assuming that your input strings were called A and B, the first character of my output is A bracket 0, followed by B bracket 0, and then A1 followed by B1, A2 followed by B2, and so on. And at the end of it all, we want a null terminator. And I made life a little easier on you. You can assume A and B have the same length. So you don't have to worry about what if these things have different lengths. And so what does this look like? Let's have string S1, which is A, B, C, D, E, and string S2, which is V, W, X, Y, Z. And we want to create some output string. And the output string is going to look like this. First we're going to put an A, and then we're going to put a V. And then we're going to put a B, and then we're going to put a W. And we're going to keep doing this. And then at the end, we're going to put a null terminator. And this is a perfect example of what I was telling you on Friday, which was in some sense the secret to the universe from a programming perspective, right? Don't try to figure out, what function am I supposed to use to do this. You're writing the function yourself. And the challenge is, using what I know how to do, how do I make this happen, right? And there is no interleave function. Well, there probably is, but don't just find an interleave function and download that and use it, right? Write code to do these steps. And so the first part of that process is, what are the steps? And so here's a game you can play with yourself, right? Suppose that you had a friend who was willing to do what you told them, as long as you told them precisely, right? And they've got, a string S1 with 5 letters, a string S2 with 5 letters, and you don't know what these strings are, but you want them to end up writing this down, right? What do you tell them to do? What instructions would you give this person? And so we might start with, okay, we'll take the first letter of the first string and write that down, and then take the first letter of the second string and write that next to where you just wrote the first one. And now take the second letter of the first string and write that next to what you just wrote. And take the second letter of the second string and keep going until you're at the end of the strings, and then put a null terminator at the end. And, that would be a good algorithm. That's a way to describe how these things should be interleaved. But now imagine that your friend is very literal, right? Like a computer. And this idea of keep doing this for all the letters doesn't really register with them. And this idea of, put that in the next position in the output doesn't really register for them. So how do you more precisely describe what you want this person to do? So that's coming up with the algorithm. So we got a few minutes here, so let's think about this. very literal friend, and you want to tell them some steps to perform to take these and turn it into that. So how could you describe what they should be doing step by step? So let's just kick around some ideas.
We could potentially look at just the first one, and maybe we could just add one to their. No, we can't just add one to their MC to kick them over one because it's quite worth it.
Well, I like how that sounds though.
Like, yeah, like ideally you would bump it such that each one you created a space, or you read all of the first one, spread them out, and dump it into your output.
Ah, okay.
Same thing. You can kind of dump them into the output.
Okay.
You could do it in one step, but the macro is maybe not simple.
So copy S1 to output, and then copy S2 to the output. So let's think about just S1. So, you know, the only way to access these things is using their indices. So these are indexes 0 through 4. And here's our output array. And our output, we can write indices for these. And can we think of or see some expression for where each of these characters should go in the output array?
I don't know if we could do like a 2n minus 1 type of thing.
Okay. So element 0, where does that go in the output array? What index?
Well, it stays at 0.
Okay, 0 goes to 0. How about index 1, the B?
And goes to 2.
Alright. And the C, index 2?
2 go to 4.
That goes to 4, so it looks like a pattern, right?
It looks like we've got a 2n.
Yeah, so let's copy S1 bracket I to output 2 times I. And I believe that would copy these into the correct locations in the output string. What about S2? Element 0, where do we want that to go?
I think those are going to want to go to 2i plus 1.
Yeah. Element 1, the W is going to go to 3. Element 2, the X, is going to go to 5. So this can go to output 2 times I plus 1. And we need to do this in a loop. Well, and if I'm using I for my index, so this would be for I equals 0 to, what's the largest value of I we want to do this for?
Looks like 4.
Looks like 4. So yeah, where's that 4 come from?
You could do it to index 5 to grab an alternator and just put in 2 alternators.
You could do it to 5, but potentially you could segfault, because that's also going to try to copy something into this next position, and we don't know if that exists. We're going to assume there's enough space to do what we're asked to do, which is interleave these and add an all terminator. But other than that slight possibility, yeah, we could just go up to 5, and that would work well. But if we wanted to go to 4, how do we get a hold of that 4? Or 5?
String length.
String length. So instead of 4, we could do string length. And the strings have the same length, so we could do string length of S1 or S2. And we could do minus 1. And then we need to put that null terminator in if we don't go all the way up to 5. So where does the null terminator go? And I think somebody just
Put that
answered it.
outside the loop.
Yeah, so outside the loop. And someone just said string length plus the second string length. And since the strings have the same length, we could do 2 times the string length. Set that to your null terminator. If the string length is 5, the null terminator goes at position 10. So that's the start of an algorithm, right? There's a little more detail if you listen to the video from the first lecture. We went a little further in this and looked at some different approaches. But this is the essential idea, right? Try to think about how you're going to do this step by step, and then try to break it into steps that you can actually write C code for, like, you know, things like this. Pay attention to edge cases, right? Whatever algorithm you come up with, make sure it doesn't blow up if your string is empty, for example, or if your string contains only a single character. And then go ahead and write your code, write a test program, right? Something like this, to see if it works. And then when you think you're all set, go ahead and link it with the test bed, do the assess. So we'll be playing with different variations of this throughout the week, and we'll spend tomorrow digging further into these kinds of string manipulations. But sounds like you got the right idea. All right, send me an attendance ping on the way out. Have a good afternoon. I will see you in 2:15, or I'll see you next time.